Hello everyone. Light. Light is a form of energy which helps us to see objects. When light falls on objects, it reflects the light, and when the reflected light reaches our eyes, then we see the objects. Light travels in a straight line. The common phenomena of light are formation of shadows, formation of images by mirrors and lenses, bending of light by a medium, twinkling of stars, formation of rainbow, and etc. Equal angle of reflection. We have to know about the basic concept of light. If let's say we are consider this is a plane, okay, let's say this is a plane, the angle of incidence equals angle of reflection. The angle of incidence I equals angle of reflection R. So this is considered as a plane. So these are the glass prism. Let's consider this as a glass prism. The white light reflected is content of 7 colors, which is red, orange, yellow, green, blue, indigo, and violet. Actually, we basically see light. We see light. We see objects because lights are reflecting the object's image to our eyes. Reflection of light. When light falls on a highly polished surface like a mirror, most of the light is sent back into the same medium. This process is called reflection of light. This is law of reflection of light. As we discussed earlier, the angle of incidence I is equal to angle of reflection R. The incident ray, the reflected ray, and the normal to the mirror at the point is incidence in all line in the same plane. So which means the incident ray, the reflected ray, and the normal to the mirror plane all lay in the same plane. Okay, these are the properties of image. The image is erect. The image is same size as the object. The image is at the same distance from the mirror as the object is in front of it. The image is virtual. Virtual means cannot be obtained on the screen. We cannot touch it. The image is laterally inverted. Inverted means it's like Malay we call it as songsang. Spherical mirrors. There are certain type of mirrors. In spherical mirror, there are 2 types. One is concave mirror, another one is convex mirror. Concave mirror is a spherical mirror whose reflecting surface is curved inwards. We can see here it's curved inwards. Rays of light parallel to the principal axis after reflection from the concave mirror. It means that the light rays will reflect inwards in a concave mirror. Meanwhile, in convex mirror, where the right of light parallel to the principal axis after the reflection from the convex mirror, which means the light rays will reflect outwards of the like this in a convex mirror. The convex mirror get diverged and appear to come from a point of mirror. You can see that the light rays are diverged out of a convex mirror and it is pointed to a point F. Terms used in the study of spherical mirrors. These are the terms where it's very very important, and also we'll use these points in calculations. Center of curvature is called C. Radius of curvature is called CP. Pole is called P. Principal axis is the axis along the mirror. Principal focus is F, and like just now we saw this is the F. And focus length is a small f. Okay. Now we will see how these applications and how it works. Okay, this is a center of curvature. See, principal focus F, principal axis XY, principal focus is PF, radius of curvature, which is radius of curvature is this till this is CP, and pole P. If we notice for your information, C is twice the length of F. If let's say F is 2 meter, from here to here is 2 meter, and then C is 4 meter. C is twice the F. Okay, reflection by spherical mirrors. In a concave mirror, a ray of light parallel to the principal axis after reflection passes through the focus. In convex mirror, light parallel to the principal axis after reflection appears and diverges from the focus. As we discussed earlier, we can see clearly throughout the images, right? Okay, in concave mirror, a ray of light passes through the focus length after reflection goes parallel to the principal axis in concave. In convex mirror, a ray of light directed towards the focus length after reflection goes parallel to the principal axis. In concave mirror, ray of light passes through the center. Can you see this? In concave mirror, it passes through the center C. And convex mirror, a ray of light directed towards the center of curvature after reflection is reflected back along the same direction. Okay, we can see here the concave or convex, both the reflection angle and the incident angle are same. Okay, let's see about the images formed by concave mirror. When the object is at infinity, the image is formed at the focus. Is highly damaged, real, and inverted. These are the properties of images formed by concave mirror, which is the image is at infinity. Infinity means we cannot see the image; it's beyond our limit, our focal limit. Okay, so the image is highly damaged, real, and inverted. When the object is at C, which means twice the F, the image form is between C and F. Okay, it is diminished, real, and inverted. It is real, diminished, and inverted. Okay, the image is at C. C means at to the F. The image is formed at C. See, this is the object. This is the image. As a sign says of the object, it's real and inverted. When the object is between C and F, the image is formed beyond C, it is enlarged, real, and inverted. When the object is at F, the image is formed is at infinity, is highly enlarged, real, and inverted. Okay, when the object is between F and P, the image formed behind the mirror. Okay, when the image is formed behind the mirror, it's considered the image is virtual. It is enlarged, virtual, and erect. Okay, this is convex mirror. Okay, the convex mirror, the characteristic is so simple. It's just highly diminished, virtual, erect. That's all. For all cases, it's not. The cases could be at 2p, at F, between P and F, beyond infinity. All the characteristics are the same. Highly diminished, virtual, erect. Okay, we can see here. For example, the object is beyond P. The image form is diminished, virtual, and erect. Okay, these are the uses of spherical mirrors. Concave mirror. Let's see about the application in our daily life. Concave mirrors are used in torches, searchlights, and headlights of vehicles to get parallel beams of lights. They are used as shaving mirrors to see larger image of the face. They are used by dentists to see larger images of the teeth. Large concave mirrors are used to concentrate sunlight to produce heat in solar furnaces. while convex mirrors are used as rear view mirrors in vehicles. Convex mirrors get erect, diminished images of objects. They also have been wider field of view than flat mirrors. So we can clearly see that how convex and concave mirrors are playing a big role in our daily life. New Cartesian sign convention for spherical mirrors. There are some signs to be converted when we are doing this in a daily life or doing calculation. The object is always placed on the left of the mirror and the light from the object falls from the left to the right. All distances parallel to the principal axis are measured from the pole. All distances measured to the right of a pole are taken as positive. All distances measured to the left of the pole are taken as negative. Okay. The height measured upward perpendicular to the principal axis is taken as positive. The height measured downward perpendicular to the principal axis is taken as negative. Okay. Okay. These are the formula we use for calculations. Okay, these are called as mirror formula. The mirror formula is 1 over V plus 1 over U equals 1 over F. V is image distance, U is object distance, F is the focal length. Okay, this is the formula for magnification for spherical mirrors. For convex or concave mirrors, the magnification is height of image over height of object. Same goes to the magnification of also related to object distance and image distance. The expression is as, hold on, height of image over height of V over U. Okay, reflection of lights. Okay, reflection of light is very important. When light travels obliquely from one transparent medium into another, it gets bent. The bending of light is called refraction. Let's say this one is considered as up is denser medium, down is rarer medium. So the refraction of the light is towards up. Okay, if the up is rarer medium, down is denser medium, the reflection is towards down. So it's like more towards moving towards the denser medium. Okay, these are the basic concepts of refraction of light. So we through the image we can see that first the light is from air to glass. Glass is a denser medium compared to air. So what happens is bent towards the glass and forms one angle, and then when the glass to air, it is from denser medium to less denser medium. We can see that it's repelled. The refraction is towards the air. So the angle of immerse is this. Okay. Okay, lots of refraction of light. Okay, the incident ray, the reflected ray, and the normal to the interface of two transparent media at the point of incidence all lie in the same plane. Okay, the ratio of the sine of angle of incidence to the sine of angle of refraction is a constant. For the light of a given color and from the given pair of media, this is also known as Snell's law of refraction, which is sine R over sine R. Okay, sine I over sine R, which is a constant. Okay, reflective index. Okay, reflective index is speed of light in medium 1 over speed of light in second medium. It's simple actually. Okay, these are spherical lenses. Spherical lenses, we can consider it as one is convex lens, another is concave lens. Okay, they are reflection of spherical mirrors. These are reflection of spherical mirrors, which is known as the basic convex and concave lenses. Okay, images formed by convex lens. Okay, we can consider the basic steps are like this. So the convex lens and concave mirrors are same principle. Okay, concave lens and convex mirrors are same principle. Okay. When the object is at infinity, the image form is at f2 is highly diminished, real, and inverted. When the object is beyond to f1, the image form between f2 and f2 is diminished, real, and inverted. Okay. When the object is at 2f1, the image form is at 2f2. It is the same size as the object, real, and inverted. We can see that it is same as the convex mirror. Okay. Image formed by concave lenses, which is same as convex mirrors, which is highly diminished, virtual, and erect. Okay. This is the spherical lenses. Okay. Spherical lenses formula. Okay. Is 1 over b minus 1 over u equals 1 over f. Power of a lenses. Power of a lens is known as 1 over f. F is our focal length. From this formula, we can calculate the power of a lens. We can consider this as a tripod. Okay. That's all. Thank you.